Okay then, hello everyone. So, um, kind of waiting on the couple people to show up real quick. Shouldn't be too long. We'll wait like 1 or 2 minutes. Um, so yeah. Um, what I have planned for this class is we're just gonna kind of keep on going forward through the lesson plan thing, and so just kind of continuing the material. Uh, Again, continuing along the line of thought of how it's like we know how to program this kind of stuff, but um, it's it's hard to actually be able to do it yourself. Um, so when we go ahead and we try and do this, we need to make sure we try and really understand exactly what is happening and uh, how we can learn this process and be able to effectively do it ourselves, right? That's the goal in the end that we want to achieve. So when we go ahead and we do this, I want you to make sure that you know exactly what is happening and you know what you know what um, what exactly is happening over here. So yeah, um, as long as you kind of understand this, um, then it's up to kind of practicing it and really getting to know it, I guess, which is like the next stage that we want to go for. So we went through a couple of different techniques um, in the last couple of classes to kind of try and learn how we can go ahead and solve these problems ourselves and learn how to solve these problems and stuff like that. And it's important for us to be able to properly, I guess, um, to to really understand this, right? Because there's like multiple layers of understanding, and many times we often get stuck on like the first layer of understanding because it seems like we know how it works. And when it seems like we know how it works, then we often get um, sometimes overconfident of our ability, and that's never a good thing because many times we're missing the kind of small things that enable us to go ahead and use it in a way that um, we can solve the problems ourselves, right? So that's my goal. Through watching these videos, I hope you are able to go ahead and learn how to solve these problems yourself. So yeah, that's kind of uh, what's going to be going on and how we are going to be able to uh, move forward through these classes. So a couple of the different things that we have learned is like learning how to start the problem. So there's many different ways in which we can start the problem, and so in the case that you don't know how to just go ahead and start writing any code, it's important for you to be able to go ahead and kind of put down your pseudocode, right? The English that we can understand by just kind of looking at it. Even if you're not a programmer, you're able to understand that kind of stuff. So that's the goal of the pseudocode. And so once you have the pseudocode, then it is important um, to go ahead and be able to convert that pseudocode properly, right? If you are able to then go ahead and convert that pseudocode properly, then you will obviously run into some bugs from time to time. And these bugs, the debugging process is it has multiple stages, I guess. And so there's different stages of logic, like whether or not your code is working and all those kinds of fancy things, right? Those are many times situationally specific, meaning that from the different situations you're going to kind of get different, I guess, different things that you're going to need to go over, right? So when we go over this kind of stuff, many times it's important for you to learn how to research this stuff yourself. So this includes going and being able to try and like run through it, just going like on a piece of paper, right? Trying to count all of the possible cases yourself. And once you've gotten all the possible cases yourself, it's important for you to then go ahead and start trying to fix those mistakes, I guess, right? So we've gone through at least one problem in every single one of these sessions, right? So as you can see, every single one is purple. If it's like blue, like over here, we haven't touched them, right? So for now, we're still in Python. So what we're gonna go ahead and do is we're gonna do one of the questions in one of the two sections. So logic tends to be one of the hardest ones. So we're gonna go ahead and we're gonna do round sum over here. So round sum, I want you to go ahead and perform these 3 steps. And in these 3 steps, you got to go ahead and kind of make sure you write it down, track it somewhere, right? Because you can make a mistake in any one of these 3 steps, and it's important for you when you go ahead and go through these 3 steps that you understand which step that you might have made a mistake on, right? Because that's the only way you can kind of improve yourself, I guess. Because you can't improve yourself if you don't know what in the world you did wrong. So when we go ahead and kind of review over what's happening, I want you to kind of check your different steps with the way I go over the problems, right? So I'll give you guys a couple minutes to go through each one of these steps, and I know sometimes it can be a little hard to go through all of them. I might be going a little too fast, and if I am, feel free to either go ahead and watch the recording or go ahead and ask me to pause or slow down, and that is perfectly fine. It's all part of the learning process, and I understand that. So, you guys got a couple minutes, read the problem, do the test cases, write some pseudocode. Alright, so hopefully we were able to go ahead and get good amount of pseudocode in, really understand the problem, what's happening in this problem, and how we can go ahead and solve this. Remember, the first reaction to any sort of problem that you might be given should not be, oh, it's like super hard or something like that, but how would I solve it if this weren't a programming problem, right? Because in the end, although it is a programming problem, it is also a logic problem, right? We got to think of it in both of these aspects. We can't just think of it in the one aspect that it is a programming problem. And many times you guys, like as beginner programmers, can get stuck on this kind of stuff, and it's perfectly understandable. I definitely got stuck on it many times when I just started learning how to program, and that's because many times it can seem unintuitive. Yeah, I guess, yes. Um, so we read this problem. For this problem, we will round an integer value up to the next multiple of 10 if its rightmost digit is 5 or more. So 15 rounds to 20. Alternately, rounds down to the previous multiple of 10 if its rightmost digit is less than 5. So 12 rounds down to 10. So essentially, given three integers, a, b, and c, return the sum of their rounded values, right? So to avoid code repetition, write a separate helper defined round 10 and call it 3 times, with the helper entirely below and at the same indent level as round sum. So what does this mean? So I believe we had one of these helper methods in one of our previous programs. I can't entirely remember which one it is, but essentially what a helper method is when we go ahead and we write our program, and we go ahead and we wanna do a certain operation. There is oftentimes a certain thing that we have to repeat more than once. And what I mean by repeat more than once, which may seem odd, like, well, of course, there's obviously going to be many actions that I repeat more than once. There's things like for loops, all that kind of stuff. But sometimes there are actions that are hard to write, say, in a neat fashion inside just a for loop. And that's what helper methods are for. And especially when these kinds of methods are going to be called in more than one occasion, I guess. Like it can be called in different methods, different numbers of times, so you don't want to copy and paste the code from the for loop, right? So that's the kind of thing that you want to go through and try and understand. All right, okay, that's what's happening here. Okay, that makes sense, right? That's the kind of stuff that we want to be able to analyze. So when it tells us this, obviously this makes our job a lot easier. Like, oh, okay, well, it's telling us to make a helper function here, so we just gotta make a helper function, right? There's not much more to solving this problem than that, right? Although when you get into the real programming world, many times you're not going to be familiar with using a helper function, and as a result of this unfamiliarness, okay, we're gonna call it that. You're not going to use this helper method, and as a result of that, you're going to take a much longer time trying to do this problem, right? So it says we have a helper method in round sum, right? So it just tells us round sum, I believe, yeah, but it doesn't go ahead and tell us how many there's going to be in here. So this is the function that we're given, this is the helper method, so I guess this is a little confusing. We can put that right there. So inside round sum, we're given A, B, and C. Whoops, A, B, and C. And so we are going to round the integer value to the next multiple of 10, if it's 5 or more, right? So it's essentially just rounding. So we're going to go ahead and we're going to fill out this helper method and the main method, right? But remember, the first thing that we got to do over here is we got to try and write our pseudocode, right? Our understanding code. That's the basis of it, I guess. That's what's really going on here. So, in case you didn't know what a helper method was, go ahead and try and figure this out right now. If not, if you did know what it is, I'm gonna go ahead and do it. So over here we have round sum, right? So round sum is essentially just going to be add the rounded versions of A, B, and C, right? That's all it's going to be. Now in the round function, what we're going to be doing is first we need to take, well, what is this units digit? So units digit of n, right? And then we need to test if n is greater than or equal to 5, then we what we do is we subtract units digit from n and add 10. So in this way it rounds it up to the nearest 10, right? At least attempts to. Right, that's the goal that we're going for over here. So next thing is, after we have that if statement, we need to think about, alright, well, if it isn't greater than or equal to 5, then we simply just subtract units digit from n. So that will essentially round it down. And we return n, right? So this is going to be the else statement. So I'll give you guys about 2 minutes to make sure you understand what's going on here, and then we can move on. Alright, so now that we kind of have the pseudocode here, we're going to go ahead and turn it into the actual code, right? So this is fairly easy. All we gotta do is return round A plus round B plus round C. Nothing much else to it. Very simple. Over here, we are going to get the units digit. So units digit, we're going to call it units is equal to n%10. What is percent? Percent is modulus. Modulus finds the remainder when you divide it by a certain number. If you're unfamiliar with this, then you can go ahead and kind of Google it. What is modulus in Python? Because I'm not entirely sure. Actually, it is in other languages as well. So maybe modulus in programming. So we take units is equal to n%10, right? And then we gotta think, alright, well, we have the two cases here. So if units is less than or is greater than or equal to 5, we have that case. And then we have our else case. I'll give you guys a second to think about what you can put into these statements. Alright, so I will do the first part of the if statement right over there. So if r is equal to that, then we do n minus units. N is equal to n minus units plus 10. And I will let you think about what to do with the second part. Alright, so the second one is going to be n is equal to n minus units. And in the end, we just go ahead and return n. So we can delete the pseudocode here, and we can check if it runs correctly. And it does. So I will let you kind of figure out, make sure you know what's going on here for a couple of seconds, or minutes rather. And if you have any questions, feel free to post them. If not, we will see you guys, I believe, after Thanksgiving break. So we'll skip over a week of teaching, and we'll see you guys after Thanksgiving. Alright, so I see one of you asked, is there any way we can go ahead and simplify this program? Well, when we go ahead and we write this program, it's important for us to go ahead and identify what's a rational place to stop, right? Because technically speaking, this almost every program can be simplified into one huge long line, right? But there's not really a reason to do that. So for now, this is the most simplified you will want to get. Um, so yeah, that's pretty much it. Thank you for watching, and we'll see you guys next week. Or not next week, next week. Yeah, that's uh, it's a rational place to kind of stop because there's no reason to keep on going. When is the last class? We have not decided that yet. Yeah, um, that's something that's still gonna go on. Again, our goal is going to be trying to um, trying to make it so you guys can actually learn it. So once we finish this stage, we can move on to the next stage of the class. And so you guys can email us whatever you want for the next stage of this programming. Um, if you're interested in something specific, if you have something for a class, anything like that. Yeah. So see you guys in 2 weeks.